Hello, my mathematicians. Today we are looking at Module 13, Lesson 1, which is all about understanding thousands. Hopefully, by the end of this lesson, you'll be able to describe the relationship between two decimal place value positions to the thousands place. So, look at the spark you're learning. It says Kiana is looking at seawater under a microscope. To search for microscopic organisms, a droplet of seawater has a mass of about 51 and 3/10 milligrams. What would be the mass of 10 droplets of seawater? Show your reasoning. Well, so first I want to start with place value chart. So we only have to go to the tenths here. So I'm going to start here. We're going to put tenths, ones, tens, hundreds. So we're starting with 51 and 3/10. And then we are multiplying by 10. So if I multiply each value by 10, so if I multiply my 5/10 by 10, I'm going to get 500. If I multiply my ones by 10, I'm going to get 10. 1 times 10 is 10. So if I multiply my 3/10 by 10, if I do 3/10 times 10, that's going to give me 30 over 10, which equals 3. So then I get 513. So 513 milligrams. And again, I did 50 times 10 equals 500 because my 5/10 equals 50. I did 1 times 10 equals 10. And I did 3/10 times 10 equals 3. Okay, so I went too far. Oh, maybe. There we go. So we're okay. Deshawn measures the length of the phytoplankton under a microscope as 1/10 millimeter. Use place value chart to answer the questions. So they have one started here. So you have ones, and we have our decimal point, tenths, hundreds, thousands. So it says, which part of the chart represents the length of the phytoplankton? How do you know? So the phytoplankton measures 1/10 millimeter. So if I wrote that in here or above this, I have 0 and 1/10. So the one long shown under the tenth represents the length. So that'd be this right here. So which part of the chart represents the length of an organism that measures 10 times as much as the length of the phytoplankton? Well, if you recall, when we're dealing with whole numbers, each place value is 10 times that to the one to the right of it. So going this way is times 10. So the flat shown in the ones represents 10 times the length. There are 10 times as many longs shown in the ones as shown in the tenths. Which part of the chart represents the length of an organism that measures 1/10 of the length of phytoplankton? How do you know? Well, if the place value to the left is 10 times greater, then the place value to the right is 1/10. So that would mean that to the small cube shown in the hundredths represents 1/10 of the length. There are 1/10 as many small cubes shown in the hundreds as shown in the tenths. How could you represent thousands in the chart? Well, we've used a flat, a long, and a small cube. And we're getting smaller, so we could divide the hundredths cube into 10 equal parts. Because 1,000 is one of 1,000 equal parts. So then the length of a sea creature, the anemone, measures 4/10 inch. Early in the development, it is about 10 times as thick as a sheet of paper and 1/10 of the width of a vitamin. Use a place value chart to represent each measure. Well, the anemone, it says, is 4 hundredths. It's about 10 times as thick as a sheet of paper. So that means the paper is smaller. So that means we're going this direction. So we're going to have 4, 0, 0, 0. So we multiplied by 1/10. So if we take 4 hundredths times 1/10, we get 4 thousandths. So our 4 is in the thousandths place. And it is 1/10 of the vitamin. So that means the vitamin is 10 times. So if we do 4 hundredths times 10, that's going to give us 40 over 100. We can divide both by 10. That would give us 4/10. So let's put my 4 here. So then, what patterns in the chart can you describe? Well, the digit in the hundredths place is 10 times as much as the digit in the thousands place. And 1/10 of the digit in the tens place. So then it says, what are the measurements of the 3 items? So the anemone is 4 hundredths of an inch. Paper is 4 thousandths of an inch. And a vitamin is 4/10ths of an inch. That is all for today's lesson. Hopefully, you're now able to describe the relationship between two decimal place value positions to the thousandths place. And remember, in order to be a math person, all you have to do is be a person and do math.